Before we delve into subnetting, let's do some subnet mask review, namely default subnet masks. The Class A default is 255.0.0.0, and this tells us that the first octet of the IP address is the network portion, and the other three octets are the node or host portion. This is suitable for very large networks with a lot of computers. In binary, there would be 8 ones and 24 zeros. Class B default is 255.255.0.0. So the first two octets deal with the network portion, and the last two deal with the node portion. In binary, we have 16 ones and 16 zeros. And Class C, triple 255.0, the first three octets deal with the network portion, and the last octet deals with the node or host portion. And in binary, we have 24 ones and 8 zeros, and this is suitable for small networks with a small amount of computers. Now let's talk subnetting. What is subnetting? Subnetting is the act of dividing a network into smaller logical subnetworks. Now let's show an example of a subnetted network address. The IP network 192.168.1.0, which normally would have a subnet mask of 255.255.255.0. But when we subnet, we're going to use triple 255.240. What we're going to do is we're going to borrow bits from the host portion. This could also be represented as 192.168.1.0/28 because there's 28 ones in the subnet mask in binary. Let's talk about the golden rules or equations I like to use. Equation 1, 2 to the n power equals x. With this equation, you can find out how many subnets are possible on the network in question. And equation 2, 2 to the n power minus 2 equals x. With this rule, you can figure out how many available hosts there are per subnet. Let's show an example of this. Subnet mask 255.255.255.240. What you want to do is you want to take 240 and convert it to binary. That becomes 11110000. Now, the masked bits, or ones, tell us how many subnets we can have. There are 4 ones in the binary number 11110000. And what we do is we plug that number into our equation number 1, which was 2 to the n power equals x. That becomes 2 to the 4th power, because there's 4 ones in that binary number, equals x. So 2 to the 4th power equals 16. So there's 16 usable subnets in this particular example. We've subdivided our network into 16 usable subnetworks. Now, the unmasked bits, or the zeros, tell us how many hosts per subnet we can have. There are 4 zeros in the binary number 11110000. So now we plug that into our equation number 2. 2 to the n power minus 2 equals x. So it's 2 to the 4th power minus 2 equals x. And again, 2 to the 4th power is 16. Minus 2 equals 14. So we can have 14 usable hosts per subnet in this particular example. And that's because we can't use the first or the last. The first is dedicated to the subnet ID, much like a network ID. And the last is for the subnet broadcast address. Here's the entire table of IPs within 255.240. And this may seem like a lot of information at first, but if you look at the left-hand column, we see the subnets, which are just being shown in binary and in decimal. So the ID numbers go from 0 to 15. For each of those subnet IDs, we can have hosts between 0 and 15. The usable hosts are going to be a little bit less than that, though, because we can't use the first and we can't use the last. So for example, in subnet ID number 1, we have the host IP range of 16 to 31. But we can't use 16 because that's the subnet ID number, And we can't use 31 because that's the broadcast. So our usable range is 17 to 30. For subnet ID 2, the usable range would be 33 to 46, and so on. Let's go ahead now and subnet the network. We're going to use the network number 192.168.50.0 and the subnet mask we just showed before, 255.255.255.240, otherwise known as 192.168.50.0/28. The subnet ID I want to use is 8. So the subnet range is 128 to 143, and the usable IPs in that range is 129 to 142. So I'm going to assign the server the 129 address and the laptop the 130 address. Let's show that now. First, I want to reconfigure the IP address of the server so it can join the subnet. And by the way, when I'm making connections to the server, I usually use an RDP connection, or remote desktop protocol. Now, we said that making modifications to IP addresses on the server is the same as on a Windows client. So we'll go to the IP properties window, and we'll go to the IP address field and plug in the correct address, 192.168.50.129. The subnet mask is 255.255.255.240, and I'm not really interested in the default gateway at this point. By the way, this server does a lot of things. It's a domain controller, it's a DNS server, and since it is a DNS server, I'm going to put in its own IP address for a preferred DNS. We'll click OK and close to bind that information. And now we need to go to the laptop to make changes to the local area connection here. So we'll do that now. And we'll change the IP address, 192.168.50.130. Subnet mask is once again 255.255.255.240. And not really interested in a gateway or a DNS address. All we need to make this lab work is the IP address and subnet mask. Click OK and close that to bind it. And once again, we want to test. Be sure to test whenever you do any configuration. So we can use the ping command to connect to the server. We'll go to the command line, and first I'll run an ipconfig and just take a look at that IP address and that subnet mask. Looks good to me. You never know if it bound or not when you closed that last window, so a quick ipconfig can check that for you. And then we want to run a ping to the server, 192.168.50.129, and the magic replies have arrived. I can connect to any computer on this subnet. However, if I try to connect to computers on other subnets on the 192.168.50 network, I should not be able to do so by default without a routed connection. So for example, let's say I wanted to ping a host on subnet ID 2. Well, for example, that would be ping 192.168.50.33. It says destination host unreachable because it's on a different subnet from me. And that's the beauty of subnetting. Subnetting creates a wall between the various subnets. It makes a more secure network, and it reduces the amount of bandwidth that's being used. As you can see in this diagram, I have two subnets. Subnet ID 8, where my laptop exists, .130, and subnet ID 2, that other host I was trying to ping, .33, which by the way does exist on this network, but I wasn't able to ping it because it's on a different subnet. A computer can ping hosts on its own subnet, but by default cannot ping hosts on another subnet. And that's part of the whole reason of having subnetting. It compartmentalizes your network. It also increases security and reduces the amount of bandwidth that's being used. It reduces broadcast traffic. Now, it may become a little bit tough to work with the math in subnetting. So there are several good subnetting calculators on the internet, and I do use them. Now, you can't use these on the exam.